All right, guys. Hope you're having a great day. I'm going to show you how to set up the oscillating mass system so we can look at its energies. Okay? So first things first, I'm going to hook up a clamp to my stand. I'm going to make sure everything's real tight for this one. Okay? Here's a bar. I'm going to feed that through. I'm going to make sure I feed it through so that the threads are towards me. You'll also notice the way that the bar and the clamp is set up, it's hanging out over the stand of the retort stand because that's going to give us better stability. I'm going to go in here, grab a spring, and I'm going to hang the spring. That's why I pointed those threads outward. That's going to hold my spring in place. At this point, I can attach a 1 kilogram mass to the other end of the spring and let it hang down. I'm going to make sure that everything is stable. Okay? And I want to make sure that this clamp is as high up on the bar as possible because I need a minimum distance above my motion detector. Now, I'm going to show you something. When you hang this mass without moving it, that's equilibrium position. If you want it to oscillate, you are not going to pull down and let it go. You're going to lift up and let it go. Because if you lift up, you will not give it more energy than it can handle. In other words, it'll never fly off the spring as long as you lift it up and then let it go. And that's what you're looking at, nice vertical oscillation. You're looking for a nice smooth motion. So while that's happening and it's enjoying the ride, let's get all the sensor equipment ready. Here's my motion detector. My motion detector, if you've forgotten, plugs into the top of the LabQuest. Either port will do. And as soon as you plug it in, it auto IDs. Okay? So we're going to change this to 50 samples a second. 50. Done. We're going to change the duration. Well, 5 seconds is good. Let's go with that. Okay? No zeroing. And we're going to make sure that the motion detector is underneath, as best we can, underneath the mass. So I think that's pretty good there. We'll see once we get it going. So I'm going to go ahead and add energy to the system again. Press play. And we're going to collect our position velocity graph data. So you can see there's a bit of an issue with this. There's some weird things happening. At this point, we kind of have to problem solve. It should be a nice smooth curve if we do it correctly. I'm going to make sure that setting should be fine. No, it should be set to cart. I'm sorry. Okay, let's try this again. Let's see if that makes our difference. Just problem solving the way you are. I'm making sure everything's lined up. Let's try it again. Let's add some energy. And off we go. You can see there's a little bit of side-to-side motion. That might be the problem right now. You can see that it's not perfectly smooth here. Let's try it again. It's getting a little better. Try it again. Try it again. Ugh. I think what is happening is, you can see it's nice and smooth up here, but it's messy down there. I think it's getting too close to our motion sensor. So here's what I'm going to do. I'm going to problem solve. I'm going to take this off. I'm going to take this off. I'm going to try something different. I'm not going to just stare aimlessly and look around and say to my friends, I don't know what I'm doing. What do I do? I'm going to try something new. I don't have any friends right now in this room. So let's try this again. Now, I need something to stabilize my stand. I know Mr. Warner is busy getting us some C-clamps. They're on order, but for now, I'm going to grab some textbooks and make sure that nothing falls. There's the game on. It's a great day. It's sunny out. Right before the long weekend. Here we go. There we go. Now when I hang my mask off, I'm just going to make sure it doesn't fall. No, it doesn't. Now I'm going to take my motion sensor. Beep, boop, beep. I'm going to go back to my, and I'm just going to make sure that it's actually picking up the mass. And that's about 0.5 meters, right? Let's see, let's go from this angle, it's right underneath. Let's go from this angle, it's right underneath. We should be good. Let's give it some energy. Let's hit play. Oh boy. It's better. It's better. Let's do that again. Ooh. Perfect. Okay. It's perfect because we only need one good cycle. And what I'm looking at here, it looks like this is more than one good cycle. I'm going to zoom in on it. Whoa, look at that. Perfect. Perfect data. Position, velocity, we can work with that. Okay? The only other thing that you might have to do, or that you will have to do, is find the K value for your spring. Okay? In order to find the K value, you can use your force sensor. Force sensor hooks up into the side. I'm just going to pull my motion sensor out. You can hook up your force sensor. You can do it a couple ways to find your K value. You can zero your force sensor and use it with a meter stick to find out how much force needs to be applied for a certain amount of stretch to take some data points to figure out your K value. Or, if you don't want to use the force sensor, you can use the motion sensor and change the masses that are hanging. So, if this is my equilibrium position, like my non-stretch state, 0.589 is what my lab class tells me, when I just kind of let my mass hang, now I'm at a position of 0.497. I could subtract those two numbers, find the stretch, I know the mass, so I know the weight, mass times gravity, and so I can figure out the force, I can measure the distance stretched, and therefore I can find my K value. So whatever you do, it's up to you. Just do what feels best. All right? Good luck with that. Have fun.